Hello, everyone, and welcome back to another Safeopedia webinar. We'd like to wish you a good morning, good afternoon, good evening, wherever you are in the world. My name is Samantha from Safeopedia, and here at Safeopedia, it is our mission to support you, the EH&S professionals, operational folks, and any safety-minded individuals with free safety information, tools, and education. I'd like to extend a huge thank you to all of you for doing a great work on a daily basis and keeping us and our workplaces safe. Just a reminder, this is being recorded and we will send out a link to the recording to everyone in a few days. Make sure you keep this interactive. We have the Zoom Q&A at the bottom there. So if you have any questions or comments for the Justrite team, get them in there. We're all here for you. So make sure that you're communicating and letting them know what you have questions about today. Today, we're going to talk about the Lithium-Ion Safety Playbook, Compliance, Containment, and Risk Reduction. This has been presented today by Justrite, and I'd like to introduce you today's presenters from Justrite. We have Megan McCarthy, Chris Mark Jones, Ethan Edgreen, and Phil Z. Today, the Justrite team are going to walk you through the unique risks of lithium-ion batteries and equip you with the actionable strategies to mitigate these hazards. I'm very excited to have you all sit back, relax, and enjoy this presentation. With that, team, let's jump into it.
Thank you very much, Samantha. We're thrilled to be here talking about lithium-ion safety. So let's jump right in. Chris, explain thermal runaway to me.
So thermal runaway is where a lithium battery can fail and where the anode and the cathode of the battery meet and an internal chemical reaction begins within the battery itself, and it begins overheating on an exponential rate and doesn't stop until it leads to permanent failure. Failures could be in the form of simply melting, or at worst, catching on fire and exploding.
That sounds very scary. How afraid of this should I be?
Well, look, you know, the idea is to educate here, not to scare people off. The risk of failure is very, very low. There's about 1 in a million chance for high quality batteries to fail if they're supported by a battery management system. However, that risk is the hazard is severe if the worst happens, and also the risk increases if battery quality levels are low, or if the battery has been physically damaged through dropping or puncturing or anything like that.
So how do I know if a battery's at risk? So you mentioned dropping and puncturing. Is there anything else I should be looking for?
Well, first thing, let's talk about the style of batteries that most people are aware of, and that might be hand tools. You'll look at physical damage. Really, once the battery is about to fail, it will fail quickly. So there might not even be any sign of failure, and it can happen at any time. So it could be lying fallow for a period of time and then fail. And once failure begins, it's very quick. We're talking seconds.
And what does that failure look like?
So often that failure can start with fumes being given off, and those fumes are toxic in themselves. Once the battery's gone into full thermal runaway rather than just off-gassing, which is when those fumes, both toxic and flammable fumes, are given off. Once that battery goes into full thermal runaway and we see ignition, they're very intense flames. If it is a well-contained, pressurized battery canister, there can be an explosive force as well.
Okay, that sounds very scary. What can I do to
It can be. The risk is low, remember.
Because I'm about to go clear out my car and like all the batteries I've got in my garage. So low risk, but when this does happen, massive impact.
Absolutely.
Now, what makes these fires unique? Because I've seen a lot online of like fire department to put them out. What is the unique?
It's lithium battery fires are interesting because they are self-perpetuating. Often we've heard of the fire triangle where you need heat, fuel, and an ignition source. These are chemical fires, and they create their own environment in which to thrive. So often extinguishing methods can either not be successful, or you can think you've been successful, the battery will lie dormant for a bit and can reignite again. Because often these smaller battery packs are multiple cells. It's not just one battery in your cordless drill. There might be 15, 20, 25 individual cells in there. So even if you fully submerge a lithium battery, you can take it out, and that chemical reaction can begin again.
Gotcha. So it's like dominoes inside of the battery.
Can act as a daisy chain effect where one cell goes and perpetuates the others, but it can lie dormant. You know, if that damage is relatively superficial, and it's probably easier if we give some specifics. The thing that separates the anode and the cathode is just a semi-permeable bit of plastic in many cases, and often that can be much thinner than the thickness of a single human hair. So we're not talking about ultra robust protective measures here, and if that battery is damaged, it can lay fallow for quite some time, which is why we've always got to be mindful of not just whilst we're using equipment, but where we store that equipment.
Yeah, I imagine with hand tools, I'm maybe not as careful as I should be. When I'm done with it, it goes on a shelf, maybe it goes in a bucket. What are some things I can do to prevent creating that risk myself?
Well, let's think about, there's a couple of things, mainly segregation, and you don't want, especially when you're in an unoccupied area. So if tools are being left overnight, if batteries are being charged overnight, you want to segregate it from the rest of the plant. And often that can be, often people think it's enough just to put them on a shelf out the way, but the flames that are produced are quite substantial and can reach quite some distances. So even under some of our industrial 5S activities, we might not be locating a battery or its charging facilities in the right place, even if it is segregated on a shelf. When I'm talking about segregation, I'm really talking about encapsulating it in a safe area.
Understood. Okay. So this seems like a pretty legitimate risk. Ethan, what are we doing in terms of compliance regulation on a global scale to mediate or control some of these issues?
So globally, it's a little bit like the Wild West right now for battery regulation. So there are really specific standards for how batteries should be built, designed, and tested, but there aren't great regulations for how you should be storing your batteries or the conditions at which they should be stored and charged.
Okay, who are the key regulatory bodies that we should be looking at in the future for things like that?
So we'll probably see that from the model fire codes, so the International Fire Code and the NFPA Fire Code. They will introduce regulation eventually that will kind of govern how folks should be storing and charging their lithium-ion batteries.
That makes sense. And I know the UL just came out with some guidelines. Can you explain a little bit of what that is?
Yeah, so very recently, UL has, through its committee-based standards development system, created a standard for battery containment enclosures. So this is UL 1487. It just came out, I think edition 1 was released in February. And this is the first standard of its kind that is directed towards the design and testing requirements for a enclosure that is meant for the storage and charging or transport of lithium-ion batteries. So there are really rigorous design requirements and really rigorous test requirements for containing lithium-ion battery runaway.
So I can't put this in any old cabinet.
No, these
Okay.
kinds of enclosures are really specifically designed for kind of the containment of a lithium-ion battery runaway.
And what are some of the things that as a consumer I should be looking for in that containment solution?
You want something that will not burn, that will contain kind of not only the fire, but the projectiles from, a lithium-ion battery. There's potential for detonation. So something that is, would physically separate the batteries from your workspace.
Okay. Now, as a member of Justrite Safety Group, we've made our name on our flammable safety cabinets. Can I use one of those?
So our flammable storage cabinets are not really designed for the storage of lithium-ion batteries. They will not perform satisfactorily in the event of a thermal runaway, but the newly developed lithium-ion battery charging cabinet from Justrite that is specifically designed and tested for, the storage of lithium-ion batteries.
Okay. So flammable safety cabinets keep the fire out. Lithium cabinets keep the fire in, they contain it.
That's
that
correct.
Right?
Yep.
Okay. Okay, that makes sense. What milestones should we be looking for in terms of regulatory compliance in the next couple of years?
So over the next probably 2 years, we should see this UL standard be introduced into the fire code. So the intent is that the 2027 editions of the NFPA 1 and the IFC will contain provisions for storing your lithium-ion batteries, and they will prescribe the use of these UL listed enclosures.
So does that mean I don't need to find a solution until 2027?
Definitely not. We know that there are major risks now for, storing these kinds of batteries, using these kinds of batteries. And like Chris said, the risk is low, but it is still present. And we know that there are solutions now that can protect you and your workplace in the event of an emergency.
Okay, perfect. Chris, I'm going to pick on you again. Let's talk about
Go ahead.
Sort of what we see in the field is unsafe. So when you're walking through a facility, what do you see that indicates, like, you talked a little bit about batteries on a shelf, but what else should I be looking for when I tour my facility as sort of red flags for lithium-ion storage?
Often, if you see battery charging facilities just kind of haphazardly left out on a bench, you can kind of anticipate that they're not being looked after particularly well, potentially. And there's three major hazards. There's overcharging, there's overheating, but then there's this mechanical damage, the unseen. Overcharging, you might notice that a charging system is getting warm. Overheating, you yourself would be warm in that area, but that mechanical damage, the last person that sort of knocked a battery off the side of the workbench and it's dropped on the floor, you'd be concerned. Also, chargers that are on a workbench might also be next to some paper cloths, for cleaning down, or aerosols that might be, aerosol lubricants or cleaning sprays. They're fuel in themselves, so you're exaggerating the risk. Even if it looks tidy and nicely put away, it might be in an area with combustibles around it, be it cardboard packing areas or wooden crate areas or anything like that. So really, the best way to know that you've got a safe lithium battery charging program is not actually being able to see the lithium batteries being charged, because they're segregated out the way.
Okay, so a proper solution then is charging within a storage container.
Absolutely. And this is where you then have this dual aspect of what's useful to the user rather than what's safe for the people and plant. So if there's one charging cabinet at the back of the workshop, I can guarantee that the people at the other side of the workshop will not be using it, which is where sort of smaller cell-based charging stations could be incorporated, and that helps with the culture behind the risk mitigation.
Yeah, that makes sense. I know when I used to work the floor, if it was 3-4 stations away, I was not touching it.
No,
It had to be right in front of me, or it was not getting used. It's just an efficiency issue, especially when you're paid per piece or something. If you've got to go hunt something down, you're not going to do it.
No, exactly, and you want your tools to be at the right place at the right time.
Yeah, it makes perfect sense. So this fits into a 5S program then too.
Absolutely, and it should definitely be one of the things to look out in the 5S program.
Oh, that makes sense. So let's talk about some of the differences in terms of storage and transport. So we understand charging should be contained, storage should be contained. How does that work for transporting batteries?
So often, let's think about the disposal of batteries as one of the things. So you might have disposed of a battery because it's gone past its usable life. You might be changing up your hand tools, and you've got a whole pack of batteries that are no longer they no longer fit the new hand tools because it's a different manufacturer example. You don't know really how that battery has been treated during its lifetime. So you don't know how susceptible it is to failure, albeit a very low risk. So when transporting batteries, it's good to have a containment system that has that fire retardation capability, a bit like the US chemical Dynalock system. And these are heavy-duty cases, fully insulated with heavy-duty clasps to keep the lids in place. So during that transport of batteries, both brand new and used, if there is an incident, it keeps the fire contained.
That makes sense. So we really have to think about the battery in terms of its entire life.
It's
when it shows up.
Absolutely.
Okay. So mitigating that risk, much like when we talk about chemical storage, it's from the minute it arrives to the minute you dispose of it. It's that whole process that's got to be within your plan and on your radar.
Absolutely, and they've become so synonymous in our lives that that we don't really see the risk anymore. It's a bit like driving in your car and having a vessel full of petrol underneath your seat. We get in there and we don't realize that we're driving around a bomb. So,
what's petrol for those of us on the wrong side of the pond?
Sorry, yeah, gasoline. Apologies.
Oh, I love it. Okay, so we understand we have a risk. We understand that we need to contain that risk. Phil, talk to me about communication of that risk.
I think Chris just sort of ended on the issue about the cradle to grave situation, and certainly the industry has acknowledged this, especially when it's a new product or a new battery. Many of us, hopefully in the group here in the audience, has been aware of and seeing when you purchase a power tool that's lithium powered, or a toy, or your cell phone, laptop, or any other charging bank. You will have likely seen this graphic of a collection of silhouetted about 5 batteries together, with one of the batteries showing a flame from it, and that's controlled by the DOT, Department of Transportation, or certainly in other countries, their transportation at the federal level, to be labeled or printed right on the box. So that should be now become a familiar image for many of us. It would usually is on the underside or the side or box, as well as if it's a box that you get from one of your favorite shipping locations like Amazon, if it's going to contain a lithium battery on it, they will have likely applied a lithium DOT label with a black and white striped labeling. On the other side of it too is that the recent emergence too on the incoming side is that the disc and coin lithium batteries have also been labeled now, mainly for the hazards of the disc being swallowed, but still either way is a very distinctive orange label with the blue symbol on it to signify that this is a disc battery, and of course do not swallow and such like that. On the other side of it too, on the reverse side, we'll jump to the grave side, is the heading out to that the batteries can be considered a hazardous waste. So generally that waste vessel is being transported, it will likely have a hazardous waste label, sometimes a used battery or used battery collection, distinctive label on it. And that's also that'd be regulated likely by EPA, at least here in the US. And any other environmental protection type that might be guiding in another country as well. But in between,
So I'm not just throwing these in the dumpster.
Well, that now we're talking about the smaller stuff here. So invariably, yes, there appears to be not much control in the case with someone tossing lithium batteries into the dumpster. And quite frankly, there aren't a lot of collection facilities from the consumer level either. So we are in a bit of a gray area right now on the disposal of lithium batteries. Now, when we're talking about the larger ones that are used for what Ethan and Chris have been talking about, for that more multi-cell, or say if it's a vehicle type that's used for, say, a hybrid vehicle or that type of styles, you're looking at the cabinets and container systems, whereby those are now being required to be marked with the OSHA symbols of danger and caution. They are typically labeled directly saying lithium-ion battery storage area. Also, they can be accompanied with that familiar 5 battery symbol with the 1 battery showing flames coming out of it, whether it be in a yellow or a red triangle going around it. So, and then on the other side of it, and that OSHA unto itself does not have a clause specific for lithium. What they have done is that it currently today, because it's still in its, and by regulation standards, still in the new phase, is that it could be cited among one of 12 different code citations ranging from fire, electrical, or PPE lack of PPE handling for say, or hazardous waste, or could be an air contaminant, or it could be, and of course, as usual, this is a chemical, so therefore hazard communication. So there's a lot of this and right to know type situations. So there's a lot of ways that one could be cited if found that an accident did occur involving lithium batteries. And the other final piece here that we've come across as well is the element of the energy storage system label or sign that goes on the outside of a larger container storage area. And that unto itself identifies specific information such as the type of technology, hence lithium-ion batteries. Another one would be the special hazards. It could be a reignition issue, a phone number contact for when an emergency does break out. And then what kind of suppression system are we talking about, whether it be an automatic sprinkler system or other gas suppression systems that you have to identify. So those are some of the main areas of visual identification when it comes to signs and labeling.
Now, it's my understanding that sign and labeling, that's not just for your employees, right? That's for first responders too.
Yes, absolutely. It's what they need to see visibly aware of that. And then they could be also using NFPA diamond. So the last label that or sign I was referring to, actually that guidance has come from NFPA. So therefore, to your point about NFPA, the firefighters are not usually going to follow OSHA. They're going to follow their guidebook by National Fire Protection Association guidelines.
Okay. So it's really important that these be marked for your team to understand the hazard, but also for emergency preparedness staff when they come into a building. If your building's on fire for a different reason, That way they can identify like this is an additional risk.
Yes, they call that fight or flee.
Okay.
Fight or flee is the element of making sure they get the personnel out, but the facility is not going to be their top priority is personnel and people. And they will let the rest of the building burn down because that could be detrimental as it continues to the fire to continue to expand. It could be more detrimental to the firefighters themselves.
Yeah, that makes perfect sense. How often, Chris, how often are these catastrophic events?
I've got some data, primarily around the UK, apologies. But let me have a quick look. So in the UK, 2023, the fire services responded to 920 fires linked directly to lithium-ion batteries. Now, that's where they can link the cause. Often there's so much damage you don't know where it started. In the US, between 2019 and 2023, they recorded at least 25,000 incidents of fire or overheating lithium-ion batteries. And you mentioned something earlier on, Megan, actually, that's really interesting. You talked about just throwing these batteries away in your normal waste stream. So the waste and recycling sector in North America, they've estimated that on an annual basis, it's costing them $1.2 billion annually to fight these instances that are happening, either through loss of equipment, loss of buildings, but that's a huge value. So when we talk about low risk, absolutely. High severity, $1.2 billion seems pretty severe to me.
Yeah, absolutely. I remember when we had the wildfires here in Hawaii, that was popping up on the news that as the fires were moving, because so much of the island is populated by lithium ion, as the fires moved, there were just bombs.
Yep. Yeah, and it's as soon as that separator breaks down between the anode and the cathode of the battery, that's when you have no choice but to either contain or get out the way.
All right, good to know. So to summarize what you all have taught me here today, the risk is there. It's a 1 in a million, but you don't want to be that one.
Absolutely.
And when we talk about maintaining a safe lithium program, it's from beginning to end of that battery's life. And that containment is sealed for charging, for storage, and for disposal. Any other key points that I'm missing? Anything that you want me to take away from this?
We haven't really touched on some of the larger batteries.
Yes. Okay.
So let's talk about the expansion in the use of battery scooters.
My forklifts. Yes.
Yes. Well, there's forklift, there's scooters, there's bikes. There's now bikes where you can take the battery off and bring this great big lithium battery straight into your home and charge it. Fabulous. But the larger the battery, the higher the energy potential. And they can be really quite ferocious. So that's where, and Phil touched on it earlier, where he talked about containers. And that's where things like the US chemical container systems can be used as a fire-safe building for physically larger batteries. So there's going to be there's a solution for lots of different potential issues, both at the smaller scale, point of use with hand tools, or the transport of damaged batteries, or the storage of larger units.
Now, when you talk about those buildings, that's something I'm putting outside of my facility?
Ideally, yes.
Okay.
I can't recall the exact codes, but there has to be a minimum distance between external walls. You want something that could be linked to a central fire safety system that might have its own suppression systems, as well as being able to contain any hazards.
Makes sense. All right. Well, thank you all very much. That was very informative. Is there anything else I'm missing? Any final thoughts before we jump into the Q&A?
I think from our side, you know, it's very much the care and attention you take over these batteries, but just don't be fooled if it looks perfect. It should still be charged and stored safely, away from other sources of fire, away from other sources of heat, and away from any flammable substances.
Makes sense. All right, well, let's jump into our questions.
All right,
So,
team.
Trish,
Yeah, we have a ton of questions here. I'd love
yes.
to kick it off here. So bear with us. We have a very engaged audience, and I love that for us. So here is our first question. This person asks, as a safety professional, it is encouraged to place all batteries, charging and storage, in a separate fireproofed building. Lots of pushback. Do you concur with this preventative procedure?
I'll take that one if you want, Megan.
Yes, please.
The theory behind it is sound. You know, you are looking to segregate batteries and charging facilities from the general workflow. I get that, but when we're talking about a workshop type situation where might be quite a large shop floor, you're dealing with human nature, and human nature will want to have those tools to hand. So as far as we are concerned, it's better to have smaller, for hand tool storage, smaller point of use storage that is still coded, still tested, but can be located in a much smaller circumference. So you don't have employees having to travel to go and pick up equipment.
Yeah,
So
a little bit of
theory
a
is
product
sound.
plug here. So we have a 17-gallon benchtop lithium-ion charging and storage cabinet that we've just come out with. So if you're getting that pushback on the large buildings, we now offer a solution for those point of use battery storage too.
Absolutely.
All right, our next question, and there's a couple of parts to it, so feel free to have me reiterate it. This person asks, is there a minimum battery size that should be stored in the new UL cabinet? Does a single power tool charger need to be stored in the cabinet, or are we talking multiple batteries or very large batteries?
I can take this question. So the UL standard is really focused around the total energy containment rating, or TECR, of your cabinet. So that means any size battery. So even a single tool battery could do some pretty major damage if it were to undergo a thermal runaway. So the charger and the battery are stored inside of the cabinet, and it's for all size batteries. The standard would apply from very small containers to benchtop applications like the Justrite cabinet to very large storage areas.
Okay. Our next question. Do you advise storing in a sealed metal container the batteries in sand or sand-like material? I know that it's best for fire extinguishing agent.
So there are various products out there on the market. They range from sintered glass beads that are designed to melt and encapsulate a battery when it undergoes thermal runaway. There's a naturally occurring product called vermiculite, which is kind of like an aerated pebble, and that can be useful and can be successful in preventing fire and flame from escaping. But in those cases, you've still got fumes. That's something that you don't see. So during the off-gassing stage, which is before thermal runaway, the battery will give off toxic, flammable fumes. So yes, if it's in a metal container, great. If you're using something to reduce the risk of fire and flame, yes, it will work. But you've got to remember that these things give off toxic and flammable fumes during their failure, which can be colorless. You know, it's only once it starts burning that you see smoke.
Okay. We have a few questions coming in here about larger battery storage capacity. Is there something that Justrite offers for those larger batteries?
Yes, it does. Yes, we do. Sorry. We've got, and these are, if you sort of think of a shipping container, that style of enclosure. Our business US Chemical Storage produce these either as a standard or to very particular customer requirements. They can be full fireproof fire suppression systems in there, fire alarm systems. So yes, we do offer very large buildings, and these carry a 15-year structural warranty. They can be temperature and climate controlled, so kept at a standard temperature as well by incorporating chillers and heaters. The world's your oyster in terms of US chemical storage. They can develop and build whatever you want. At the same time, they can also advise as to what you might need, depending on your situation, the type of batteries you are storing, and the geography that you are in.
Okay.
And those are both fire rated and lithium ion, correct?
They're fire rated. Now we don't have, because of the lack of codes,
right.
we can't have a, you know, but yes, they are tried and tested.
Perfect.
Okay. This person asks, we have a 5-gallon plastic pail for our waste lithium batteries purchased through Waste Management. It is stored on the dock. The lithium batteries have their terminals taped. Is this stored properly?
I'm going to say no. I kind of know what you mean, and you often see them in supermarkets sometimes where there's a recycling point. The problem with this is guaranteed it will not just be lithium-ion batteries that are put into that pail. There'll be all types of batteries in there. There'll all be all types of additional waste. And just because you're taping up the terminals, and I understand why it stops them creating a circuit within themselves, you don't know what damage or what condition any of the batteries are that you're throwing into that pail. That's where the US Chemical Dynalock box would be useful, because yes, you can still put it in there, but you can clasp that lid shut. You know that once that lid is clasped, even if there's a failure, it's contained. Great idea to stop them going into waste, but again, a greater risk if something should happen, and a risk of mixing battery types as well, which makes the chemical hazard even worse.
Great. Yeah, there's a lot of questions coming in regards to proper storage prior to disposal. What are the steps that they should be taking to ensure that they are properly storing before they do get that chance to dispose?
Always depends on the physical size of the batteries. Our lithium battery charging cabinet can quite easily be used for storage as well. So it might be that you have one of the cabinet, if you're only dealing with a handful of smaller batteries, you might have one cabinet that is designated as a used battery storage. But even if you think a battery is dead, as in it holds no charge, doesn't mean to say there is no risk. The risk is less because the energy capacity is less, but the risk is still there. and it's the secondary fires that you've got to be concerned about as well. The actual battery fire is very quick, very ferocious, reaches temperatures of 800 degrees C, so 1500 degrees Fahrenheit. You know, they're severe.
Okay. A couple of people are asking about fire extinguishers that are rated to handle lithium-ion fires.
I'm sure you're bored of my voice, but I have got direct experience of this actually. When we were doing testing with the London Fire Brigade, we actually tested a couple of these extinguishers, and what we couldn't determine, or what the firefighters couldn't determine, is whether the battery burnt out by itself because it's so quick, or whether the extinguishers had the effect that they're designed to have. There are a number of different extinguishers, both capsule pressurized extinguishers, and they're always a dry extinguisher. They can determine whether the extinguisher actually put out the fire, or whether the fire went out by itself over time, because they are very, very swift, the fires.
Okay, thank you for that. Another question, we have a few questions here about runaway. They're asking what causes it? Is there a prevention procedure? And do you have any information on regulation that is being looked at for runaway prevention, the care, and what's the best practice?
So Samantha, we're going to be sending out an infographic that talks about the different risks of thermal runaway and how to visually identify whether or not your batteries are exposed. So when you get your recording, make sure to keep an eye out for that visual guide for battery damage.
Perfect. Yes, we will be sending everybody a copy of this webinar in a few days, as well as any handouts and as well as that infographic that Megan just discussed. So be on the lookout for that for more information. We're also going to connect you with the Justrite team. They're going to receive all of your information and all of these questions. So if we don't get to your questions or we missed you, we will be connecting all of these questions with the Justrite team. So if you wanted to reach out to them, you wanted them to reach out to you, drop it in the chat. We'll let them know and they will reach out to you and make sure that you guys get all of your questions, your concerns answered to keep you safe. All right, let's see. We have an abundance of questions here. Question is there currently a requirement for Tier 2 registration and annual reporting or waste reporting?
I'm out from this one, Megan, I'm afraid. You're up.
So I don't know that we would be maybe the best resource for this, but I think the EPA would provide guidelines for the waste reporting aspects of lithium-ion batteries.
All right. Let's see here. This person wants to know, do you have any recommendations on how lithium-ion battery safety can be approached in an academic institution to keep students safe?
Well, actually, that a lot of the work that we did was in conjunction with University College London. They have a very extensive lithium battery research facility. They have cabinets. They store their batteries for testing purposes in fire-rated cabinets. When they saw some of the ways that these cabinets performed, they'll probably be changing their storage methods. So in the same way that you use a flammable safety cabinet probably for chemicals within a chemistry lab or anything like that, we're talking about a similar risk, a similar severity, but this is a new risk that we're coming across, relatively new risk to us as the population of batteries increases. So I would observe the same care and attention that you do with some of the chemicals that are stored around your students, and that's using correct storage methods.
Okay. This person says, Chris, so glad you mentioned shipping container size storage. We have multiple air-conditioned containers on our shipping port in Florida. They are in a centralized traffic-controlled area to keep heavy equipment from making contact with them. Are there any other options that we should be considering?
You may want to think about remote alarms. That's something that we can fit to our buildings, you know, so that you know that, and if the container is separate to the main population, you want to know that something has happened, especially if a site is not populated at nighttime, for example. You want to know that something has happened in that storage location, either through a remote alarm, something visual outside, because you may not know that a battery has failed within the storage unit itself. So that's something that's one of the major things that I would suggest. You want to know that an incident has occurred without you having to open the container itself.
Okay. What are the best practices when it comes to active use of the batteries when you need multiple batteries on hand for a particular task? Are the main concerns for charging and storage in particular, and not a concern when the batteries are actively being utilized during a task?
Go back to the 3 failure modes. There's mechanical abuse, thermal abuse, and my mind's gone completely blank onto the third one. So mechanical abuse, electrical abuse, and thermal abuse, sorry. So electrical abuse, you can think of it if it's overcharging. Often the higher quality systems have very good battery management systems, and that's a lower risk. For me personally, it's the mechanical abuse. So, you know, if operators drop a battery, things happen. If you drop a battery, if it gets knocked off a workbench, probably the best thing to do is to segregate that battery and use a new one. There probably won't be any incidents, but at least you've segregated that battery, not knowing that if any internal damage has been created.
Chris, a quick follow-up on that one. I've read that you can overuse these batteries as well. How intense is the risk of running a battery down to 0 every single time?
Lithium batteries are actually, we're kind of used to using a sort of a good band, a most effective band within a battery, and that you should never let, when mobile phones first started coming out, you were always told never let it go to 0 because you'll damage the battery. You do want to have a level of charge in that battery. You don't want it to go completely to 0. But for me, it's predominantly mechanical abuse that you have to be wary of with a lot of the hand tools.
Makes sense.
This person asks, do the containers for the batteries have any kind of ventilations for the fumes you spoke of for when you open the container?
So I think Ethan might be able to tell you more about some of the engineering controls that we've put in place, especially with the charging cabinets. But the idea is you do not open that cabinet. You let the professionals, the firefighters, deal with that hazard. You are confident and comfortable knowing that if an incident occurs in that closed cabinet, your property and your people are safe. You don't touch it. You let the experts do that. But we do have a number of different features in our cabinets, and I'll let Ethan talk through some of those if you want to, Ethan.
Sure. Yeah, like Chris said, you do not want to open the cabinet if you know that a thermal runaway event has occurred inside. Our product features cooling vents that, in the event of thermal runaway, shut to contain those hazardous gases. And then we provided really dense blast vents in the front to relieve pressure from detonation in a thermal runaway event, but then still contain the hazards.
Okay, good to know. This person would like to know, do the storage practices and procedures change for lithium iron phosphate versus lithium cobalt or NMC?
I'm not a battery battery expert in terms of their full makeup, but I think the major difference is the separator material. I know that solid state batteries, as they're starting to come out, will be a lot safer than existing lithium batteries. But I think one of the things we've got to recognize is that they're everywhere now, and industry has invested heavily in our current battery technology. New battery technology is coming out all the time, but in terms of common acceptance, it's predominantly this sort of anode cathode separator type battery composition that we see in industry and at home as well.
Okay, great. And this person asks, we're working in a lithium battery recycling facility. What risk exists once the anodes and cathodes are separated and stored or processed?
That's a hard one for me. I think you're really dealing with chemical hazards then, rather than flammable hazards if you're or explosive hazards if you've separated them. Good question. I don't know. We would have to come back to you on that one.
Okay, perfect. And that's a great reminder to, again, let everyone know that we will be sending all of your questions to Justrite, and they can reach out. You can reach out to them. We'll connect you, so make sure that you look out for that as well.
Yeah, that would seem PPE would be involved in that as well for handling, especially now that you separated the anodes and such.
Okay, great. This person wants to know, what is the max energy capacity to store in a Justrite container, or where can we find that data?
So for our lithium-ion battery storage cabinet, it's currently rated at 4 kilowatt hours. So that means you can store and charge up to 4 kilowatt hours worth of batteries. And all that info is found on our website.
Okay. And there's a few questions on standards or best practices. Is there a standard for testing of the storage container?
So that standard is part of the new UL 1487. So within that standard, there are test requirements. So internal thermal runaway testing, and then also internal thermal or deflagration testing. So like a detonation inside of the cabinet. So that test standard contains some structural requirements.
All right, gotcha. Well, we do still have some questions here. They're kind of all, they've been answered already by other questions that have been asked. So make sure that when we send you the recording, you take a listen to this Q&A session because your question was likely answered. And someone asked, what's the best way to educate your workforce of the dangers of lithium-ion batteries? I'm going to reiterate, let's watch this over again, roll the tapes, and reach out to Justrite because they have an abundance, a wealth of information. They're going to keep you safe. They're going to put you in the right hands. So before we wrap it up today, team, I want to say thank you for all of your insight, but I want to reflect it back to you. Are there any parting words, takeaways, anything you want our audience to keep top of mind so that they can be successful in keeping their workplaces safe?
For me, it's just safe segregation. Keep those batteries away from everything else.
I would say that certainly proper identification is critical and important. Visual communication is always important in a workplace and workspace so that you're aware that if you are working in, near, and around such hazardous products, regardless of whether it's lithium ion, but certainly in this case, the batteries, you will have been notified by reading the signs and labels.
Fantastic. All right,
And I'd
guys.
just like to add to that, if you have questions, if you have product questions, the team at Justrite, we offer several lithium-ion solutions. So please reach out and we'll help you get sorted.
Perfect. Well, Megan, Chris, Ethan, Phil, thank you so much for being here today. Thank you for educating us. This is something that we deal with on a daily basis, and I think we kind of forget. I think we kind of forget how to store properly. I think it's sort of become complacent, so it's always a nice reminder to go back to basics and keep our workplaces safe. So a huge shout out to you guys, a huge shout out to Justrite for being here today and allowing us to put this on. And of course, I want to thank all of our dedicated safety professionals and the audience, because without you guys, none of this would be possible. So keep an eye out for the follow-up email with all of this great information and the handouts from Justrite. Reach out to your Justrite reps and make sure that you keep our workplaces safe. So thanks again. Take care, and we'll see you next time. Bye, everyone.
Thank you. Bye-bye.
Thank you, everyone.
Thank you.